So, as Nigel has said, I'm Ellen. I work in the Environmental Department of BBS. My main focus is on domestic new builds, but I'm going to cover in this presentation domestic new builds, a little bit on non-domestic, and also a little bit on refurbs. Thanks very much to Paul, who's very nicely summarised an overarching view of what's happening in Part L. Hopefully, this presentation will help you to understand a little bit more detail about what's going to be going on. I want this to be good for everyone. I want everyone to interact. If you've got any questions as we go along, please just shout out, because at the end of the day, you're here to learn, find out a bit more about what I know. And if there's something I missed or haven't explained properly, then please just let me know. So, I'm going to have a little bit of a background on what's been happening so far. So, back in 2006, we had a revision to Part L. Everyone should be very familiar with this now. SAP 2005, we were looking at basically you had your target dwelling emission rate and you had to get lower than that to pass. Quite surprisingly, we've still got quite a lot of sites going through under SAP 2005, so it just shows you that it takes quite a long time for the industry to catch up. It doesn't seem like that long ago that I was stood here talking to everyone about SAP 2009, but that now is something that obviously anything now that's being registered under building control is being assessed under SAP 2009. That represented a 25% improvement on 2006. And you should all be quite familiar with the fact that we were then looking at insulating party walls, a lot more focus on thermal bridging, fabric first approach, and also we had this fabric energy efficiency come in, which was quite closely related to the new version of the code, which was in November 2010. And now we're going towards SAP 2012, Building Regs 2013, and the target now has increased a further 6% since 2010, which represents about 31% improvement since 2006. The government sort of pulled this back slightly. We were hoping to see about 44% improvement, but based on what Paul said, they're trying to push a bit further forward without making it too hard for house builders. So, Part L has been delayed from this April to next April, so D-Day now is 6th of April 2014, and as Paul said, that basically leaves about 5 months to get the software sorted, get our heads around it before it actually comes into effect. I know that Paul has seen a copy of the approved documents, but officially the approved documents for April 2014 haven't been released. They were due mid-October, and we still haven't seen them. And I was also hoping to show you a bit of the beta software that the BRE have been producing, which is called CSAP. But unfortunately, we're still waiting for this, and we're still waiting for this. So what I'm going to do is I will take you through a few examples of SAP 2012 later on, but I think I'm going to do quite a little bit more work on it when the CSAP is released. I'm hoping within the next 2 weeks. So I'll send out a bit of a secondary presentation which should give a bit more detail about different scenarios with that, so keep your eyes peeled for that. And moving even further forward, Paul also talks about this, obviously going to zero carbon in 2016. Andy, my colleague, is going to be taking through a lot more detail of that later, so I'll leave that part and just concentrate on 2013. So, Criterion 1 states that the dwelling emission rate needs to be less than the target emission rate, and this is something we're all very familiar with now to get a pass. But we now have a lovely new part to it, which is called the dwelling fabric energy efficiency and the target fabric energy efficiency, and this is based on the kilowatt hours per metre squared fabric. And the acronym of DUFI and TUFI. So what we're now looking for is a two-part compliance. So we want, obviously, definitely to see the DER is less than the TER, but also the DUFI needs to be less than the TUFI. And this, for me, was quite a surprise when this came out, because I was involved a little bit with the consultation of Part L, and this basically came out of nowhere, this DUFI and TUFI. So I was, bit of hilarity came with that. But before we talk about DUFI and TUFI in more detail, I'll just take you through a little bit about what's happened to the TER. So the first time we saw TER was back in 2001, and then as time's moved on, we've had sort of an improvement every time of what the TER needs to be on the dwelling. So in 2006 it was improved by 20% from 2001, and then again 25% in 2010. that sort of improvement's all sort of been scrapped now, and what we're actually looking at now is this elemental recipe, which Paul alluded to, is supposed to make it a lot easier for architects, designers, developers to work out what will comply with SAP before they actually have a SAP calculation done. So this is called the elemental recipe, and I will take you through what the elemental recipe is shortly, but what it basically is excuse me, a list of U values and specification which can be applied to pretty much any dwelling, and you'd expect to see a pass under SAP 2012, sorry. And this Appendix R of SAP 2012 is going to be a new appendix within the SAP document which will run through the elemental recipe. It will have lots more information on thermal bridges, hopefully a lot more psi values available that have been calculated, and they should hopefully be a lot more accurate. However, I can't tell you much about Appendix R because it's currently missing from the SAP document. We're currently waiting for that to be entered too. So DCLG have sort of delayed the release of the approved documents, but that has obviously had a bit of a filter down to the fact that some of the parts of the SAP document are missing at the moment as well. So again, when this becomes available, I shall have a look at it, find out all the gossip from it, and let you know what's happening. In terms of backstop U values, there's actually been no change since 2010. So they've left them exactly the same. So your maximum U values can still be as follows: 0.25 for ground floor, 0.3 for wall, 0.2 for party wall, roof 0.2, well, as you see up there. But as we all know, this is pretty irrelevant because it's never going to pass on the backstop U values. So it gives you the flexibility if perhaps you have got one element which is worse than another. However, if I was you, I wouldn't even entertain looking at these for thinking that these are going to help you to pass, because you know, things like windows and doors at 2, no one puts in windows and doors at 2 anymore. Party walls would always really be recommending fully filled and sealed, which is a 0 U value. But this is just to let you know that, yeah, if you did have one particular element that fell a bit higher, then you wouldn't be penalised. But here is the elemental recipe, so I'm just going to bring them all up. This is what they say is what we need to do to pass SAP 2012. So we've got ground floor at 0.13, external wall 0.18, party wall fully filled, roof 0.13, windows at 1.4, air pressure test at 5. We'd definitely be expecting to see all units tested at that, otherwise you'd need a 3 and add the penalty of 2. This is based on natural ventilation with extract fans, so they're not requiring any centralised extract, 89.5% gas boiler, and thermal bridging to ACD. So just to see if anyone's got any reaction to that, does anything there scare anyone particularly? I personally feel the external wall is quite challenging at 0.18. Yeah. You're going to be increasing the wall cavity to do that, unless...
I've been using these values for the past year, to be honest with you,
well,
so they're not new to achieve the code. With
yeah.
0.18 you go 18 mil Celotex and you get 0.18. It's not...
Yeah, okay.
It's not unusual, to be honest.
Yeah, I think this was the idea of having the elemental recipe. The idea of the code, obviously, was to push things a bit further forward. So if you were going for code 4, say on...
Exactly.
Yeah, yeah. And this is obviously a fabric first approach. So there's a lot of emphasis on going for fabric first, and this is why the DUFI and the TUFI have come in, because you can no longer build sort of a poor fabric house and whack on the renewables to pass. There is going to be the TUFI you have to meet. But what they're saying is, if you put this recipe to pretty much any dwelling type, that you should achieve a SAP pass. And as Paul said earlier, I think this really was to make it a lot simpler for developers and designers, just to have an understanding of what is needed to pass. I know when we were looking back at SAP 2009, there was a lot of uncertainty about the effect of orientation, thermal mass. There was a lot of new items in SAP 2009, which I think made a lot of people wary about when they were designing, were they going to pass. And I've done a lot of work over the past couple of years with helping people at tender stage to check whether they're going to get SAP compliance. And obviously that's a lot of extra work, a lot of extra thought that developers have had to put in. So hopefully this will make things a bit simpler. I mean, I don't think the window U value is particularly difficult. 1.4 should be quite achievable. And even the ground floor, I mean, you're probably looking at 100 to 120 mil of Kingspan or Celotex. So yeah, this thermal bridging to ACD, again, hopefully when we get more information about the psi values in Appendix R, there might be some more flexibility there, but we've also got quite good details available from places like Constructive Details, Thermalite have produced their own ones, so there are, yeah.
Well, I was trying to wait for you to finish, but one of the big problems I think with a lot of these increased amounts of insulation is the condensation risk.
Yeah.
I know I looked for a client who wanted a large amount of insulation. We looked at doing 140 mil rock work inside with lightweight rock work, and then putting 100 mil Celotex in an external in a cavity.
Yeah.
And there was a condensation risk in that construction, and we lowered the Celotex to 70 mil to take out that condensation risk. And I think increasingly as we get these improved new values, we've got that risk.
Yeah.
Otherwise, we've got to be putting an impervious layer on the inside of the walls and making sure it's totally intact. And if you look at some of the constructions that we've got with stud work and that sort of construction, we're putting services into those walls which always end up with electrical penetrating those. And maybe we've got to rethink having some sort of zone on the inside of the house which has a layer that we run our services in to get overcome.
I think that's a very valid point. Obviously, as the U values get more onerous, there are going to be different and conflicting issues that come up in terms, even things like sound and things like that. And especially as we're hoping to have a very airtight building as well, when you're saying about increasing the insulation and putting, like say, this internal lining in, it does make it very challenging. I don't think that's been fully considered, obviously, by this. They're just pushing the U values harder and harder. It's going to come to a point where there's going to be no point pushing the U values any harder, because the power of diminishing returns, that there's only so far you can go that's actually going to make an impact. So obviously we've got zero carbon like 2016 literally just around the corner, really, so it'll be interesting to see what the recipe is going to involve for that, because I really think much further than this. I mean, you could probably push the external walls a bit further, but it's going to be getting a bit stupid, to be honest, but we shall see. So within the recipe, you do have flexibility with the ingredients. So you could, if you wanted, say, make the wall, U value of the wall a bit worse, and then but obviously what you have to do is make it up within other parts of the building. But providing you meet the TER, you meet the TIFI, and all the backstop U values are met, then within that recipe you have quite a lot of flexibility. So perhaps if you found a supplier who provided really good value triple glazing and decided to really improve on your windows from 1.4 to 0.9, then you probably find with your external walls you could increase that. But again, that would have to be something that you weighed up on a project by project basis. But overall, the recipe is really just supposed to simplify things, make it easier, and hopefully make it a bit more straightforward. But we shall see if that happens. A little bit more on the TIFI and DIFI. So as I said earlier, it's related to this fabric energy efficiency, which is measured in kilowatt hours per metre square per year. A lot of people who've worked with Code for Sustainable Homes assessments will be familiar with the fabric energy efficiency, as it forms part of the Energy 2 assessment. So within the code, they set targets for, say, semi-detached dwellings, detached dwellings have to meet a certain target. But it's very restrictive. So what this DIFI and TIFI do is it's actually based on a notional building. So if you've put into the SAP a semi-detached dwelling of 76 metres squared, the TIFI will be related to that exact dwelling type. So it takes into account the amount of party wall, the amount of external wall, which is a lot more fair than just picking out a standard semi-detached which was set at a certain level. And what they've done is they've given a 15% relaxation for greater flexibility. So what that means is the target is actually 15% lower than what the notional building target is. So that's supposed to make things slightly easier in terms of compliance and give you a little bit more flexibility within the U values. And we'll have a little look in a minute at some examples. So just to quickly go through what will actually affect the diffie and tuffy, this is really the fabric, really, thermal bridging, the air tightness and the orientation. So putting on renewables and things like that, and the heating system, ventilation, they won't actually affect the diffie and tuffy at all. So if you're struggling to meet your tuffy, you need to be looking at your fabric, you need to be looking at your air tightness, and this is to ensure there's no over-reliance on renewables. So again, pushing for this fabric first approach through that. So the DER, TER, the U values, the thermal bridging, the air tightness and the orientation obviously affect the DER and the TER, but over and above that you can obviously make changes to your heating, your mechanical ventilation, your lighting, and you can add on renewables. But as I said earlier, this won't affect your diffie and tuffy, and you need to comply with both to get a SAT pass. So it's no longer just a case of getting your DER down any way you can. Let's whack on some solar hot water. If you don't meet your tuffy, then you won't get compliance. So it's really just to bear this in mind when you're sort of starting your design, to think, get this fabric first in early. I don't know if anyone remembers this, if anyone was here a few years ago when we introduced the BBS house. The idea of the BBS house is sort of a standard house type, which we have a bit of a play around within the SAP software, and we can let you know a bit of a realistic outcome. As I said earlier, the actual software was supposed to be out on the 5th of November, and unfortunately hasn't materialised yet. But these are real examples, but what I will hope to do is when the software comes out, give a few more different examples, because some of these might be things that you think, well, we wouldn't actually do that, and so we'll run through them anyway and see what you think. So what I've actually done here is applied the elemental recipe to the BBS house, which is just the standard semi-detached house. As per the elemental recipe I went through earlier, I've put in all the U values, the air permeability, and the heating and hot water as per the recipe. And the result of that is literally just pass. And your diffie is, well, that is actually 15% lower than your tuffy. So that's sort of like a standard pass house type. This is what they say is work, but obviously I haven't actually had a play with the software yet, so I can't guarantee that it's exactly what's going to work. But this is the idea of the elemental recipe, and that would make you Part L compliant. So that should hopefully make things a bit easier. If you wanted to change the recipe slightly, like I said earlier, if you've perhaps got some really good triple glazed windows at 0.9 U value, it would actually allow you to relax your U values on your ground floor and your external wall. So the difference between having a 0.18 external wall and 0.22 can sometimes be quite significant, and depending on the type of development you've got, you might find this actually works much better. Again, the ground floor could go up to 0.16, but everything else stays the same, and you've just complied there. Your DER is probably about 0.2% less than your TER, and but you see there your diffie has gone up a bit because you've relaxed the U values on some of your larger elements, but you've still complied. All you need to do is get below that tuffy. There's actually been no mention at all about any percentage improvements. I know previously when we talked about SAP 2009, we were quite involved with the code, talking about 25% improvement on this. As Andy will talk about later, to do with the code, there's been no mention about any sort of percentage improvements, which indicates to me that the code is going. But all we're really looking for is DER less than TER and diffie less than tuffy. So you'd be Part L compliant. If you wanted to relax the external wall even more to a 0.26, which I think you'll find, I think that's very much achievable. If you the suggestion is you could add wastewater heat recovery. I personally don't have a lot of experience with this. This is one of the BRE examples, but if you did that, you could still comply. But obviously your diffie has gone very high, so that's about the maximum you could go to, I think, on the U values, because if you push the U values too high, then you're not going to meet your target fabric energy efficiency rate. So you see there, I don't know if you can see that, but you're 54.2 for your diffie and the target's 54.26. So we've just scraped in. It still complies, it's not a problem, but if you put your external wall up to 0.27, think that you wouldn't comply because your Duffy would be too high. Another option would add some PV. So see again here, your Tuffy's gone up. This is actually a detached house this time, so your Duffy is slightly different, but we've pushed the Duffy right up to the maximum there. We're passing by 0.01, so effectively what we've done here is push all the U values as high as we possibly can. So 0.2 for your ground floor, 0.26 for your external wall, and 0.18 for your roof, which I think everyone will agree is pretty much what we do now, if not a bit worse than what we do now actually. And that 0.48 kilowatt peak, that's what you need to just pass, but probably on a house that size, that's a bit undersized anyway, so you'd probably find your DER would get better, but because we're not really trying for any sort of percentage improvements or anything like that, there doesn't seem much point in putting on what you don't need. So I think the message really is it's a balance between your DER and your TER and your Tuffy and your Duffy, and there is flexibility within the recipe, but it's just how you sort of want to build it. The last one is solar hot water. So again, relax the U values quite a lot there and put on 4 metres squared of solar hot water, which would be for a detached house, so it's probably about the right size. And again, see, that hasn't actually affected your Duffy and Tuffy at all, because renewable technology won't affect those results. That is basically just based on fabric energy. I know I just rushed through all of that. Does that make sense to everyone? Is everyone sort of understanding that it should be a little bit simpler, hopefully?
Sorry, just quickly.
Yeah.
Through that, I'm just tracking it. Did the Tuffy change?
Yeah, because I went from a semi-detached to a detached house halfway through. Did I not say that? This one,
I think you did.
yeah, the ones for the PV and the solar hot water are based on a detached house, which is 118 metres squared. So if you see there, the Tuffy's gone up to 59. But the fact is the Duffy is based on the notional building, it will change whichever house type you do, but it will be relative to the house type you're going to build. So it does make it more fair. There's not these just random levels that you need to meet, and each individual house on a site may well have a different Tuffy you need to meet. So
it does take into account things like exposed area?
I think it's going to take,
That was an issue, wasn't it?
yeah, it's going to take into account, so if you've got a flat with only one external wall, it will basically mirror that, and it will work out the Tuffy, and it will give you a 15% relaxation. So it will be a lot more fair. I mean, at the moment we have issues with the code where we're trying to get flats which are more like semi-detached houses to pass under flats, and this was a bit of a worry when we were coming up to SAP 2012, because we weren't really sure how they were going to measure this. I think it's been realised through the code procedure that it was a bit of a mess really, and it's got a lot of people a bit confused. So this part of having the notional dwelling, it should make it a lot fairer. So the fuel factors are, probably people know quite a bit about the fuel factors, but what we do with the TER is obviously based on a gas. Gas as the main heating, and what the fuel factor does is it relaxes the TER for any homes that aren't on gas. So you've got their LPG, oil and electric, and so it makes your DER a bit higher, so it's easier to comply if you've got a different fuel. What they've done is they've retained the fuel factors, but they've rebased them to align with the new TER methodology, which we talked about earlier, and also the DEC carbon emission factors. But as always, this isn't going to change. It is tougher to get compliance where you're not using gas, so you need to have a think about that, especially electricity, electric heating. It's a lot harder to get compliance, even though your TER is increased. I'd still, recommend not going for electric if you can possibly help it, because you're going to have to top that up elsewhere. I'm just going to touch a little bit on design versus as-built performance. This is something which hasn't really been brought in this time around, but we're starting to have a think about. The Zero Carbon Hub have been working on looking at whether the design stage SAPs that we all carry out and as-built SAPs are actually at all relevant to what's actually been built out on site. I don't know what anyone's views on this is, but obviously we put in different U values and we say that the walls going to be party walls going to be fully filled, and on site, is this actually being carried out? Are the thermal bridging junctions actually being done correctly? This is all related to the fact that from 2020, they want to see that at least 90% of all the dwellings meet or perform better than the designed energy carbon performance. So they want to be able to compare in 2020 an as-built finished property with the SAP calculation, and they want 90% of all the houses to actually meet the design stage performance, which I think is quite unrealistic, but we shall see. That what they've said is there's a massive gap at the moment between the design and the as-built performance. So what they've been doing is, throughout England at the moment, we've got quite a lot of large developers signed up to participate in looking at this design versus as-built performance. So there's over 100 homes on sort of large developers' sites that are currently, they're analysing the design stage SAPs, and they're having a walk through the site, they're having a look at what's being done, looking at the thermal bridging details, making sure the insulation's going in properly, taking photographs and sort of compiling some data to just check what's actually happening. But the problem we have is there's not really a test we can do on a house when it's finished to say, has this met the design stage SAP? So Nigel said earlier that we're looking into doing some thermographic imaging. This is one potential way of looking at whether a house performs as it was designed. However, this is a nice, pretty picture, but there's actually nothing there that says yes, this meets the SAP, this doesn't. It needs quite a lot of interpretation. You can't really tell directly from looking at a thermographic image whether it has met the design stage SAP. Another option is co-heating. This is a picture of co-heating going on in a new build flat somewhere. This is quite a delicate test. It needs to be carried out between October and February, so it's got to be carried out sort of winter months. The house needs to be finished. They need to be in there for 2 to 3 weeks to use electric heaters. They basically bring the temperature up and then they measure the amount of energy that's leaving. So it's quite an intensive, disruptive process, which I can't really see many developers signing up to. Imagine if every single house on your site had to go through this. I can't really see that happening. So at the moment, there's not really any tangible way of testing what the gap is between design and as-built performance. So we're still waiting to hear about this, but I think as we go forward, this is going to be something that's going to come into it a lot more. We talked back in 2009 about perhaps doing a QA on thermal bridging. That's all completely fallen through and we've lost that completely. But I think in the future something like this is possibly going to come out, so it's just keep your eye on it.
Is it too simplistic just to have remote metering, positive or negative metering? Because at the end of the day, if you look at renewable incentives, that's all based on heat metering.
Yeah.
So why not just have heat meters, either positive or negative, so they're connected up to a modem or whatever, and just collect the data centrally? Yeah,
I think that is a way that it could be done. I mean, we're working with quite a lot of planning authorities at the moment which are specifying this in their planning conditions, that they want remote heat metering to check the performance not only of the building but the renewable technology and things like that. So it's possible, but obviously the service
is dependent on the occupants. Some like it cold, some like it hot, some open the windows, some don't.
But that's the point, it's real life performance,
But
isn't
you
it?
don't know how the building's performing, only how the occupants are treating it.
You do know how the buildings are performing because
You've got
at
someone
the end of the
that
day
wants
it's all about
heating on
energy consumption,
constantly.
isn't it?
It is, but you could have someone that likes their house like a greenhouse, so their energy consumption is a lot higher than someone else that likes it cool and doesn't want to keep the heating bills. So you're very dependent on occupation, what a style of living.
Yeah, I think that the energy use would certainly come into it, but what I was looking at in the previous test was looking at the actual performance of the wall, the build quality and things like that. I know that it is related to how much energy people use, but conversely, you could
but
say...
you can also factor that against outside temperature.
You should get into this, obviously.
Yeah, but shouldn't there be more building control inspectors or some sort of inspectors making sure these details are actually being executed on site rather than trusting the builder that he's ticking the box and I've done this?
Yeah, well, we've got lots of building control people here, so obviously they've got lots of experience of what it's like going on site, checking details. I do think, Part L is just one part of the building regs, and I think sometimes in terms of the installation that's going in, yes, building control will go and have a quick look, but maybe someone would like to say about how much you look at thermal bridging details and things like that on site. Right.
No.
Right. So but you're right.
I've been to several new homes which have had problems where they have been signed off, but you still have condensation or they've missed installation somewhere. So we're trusting the builders to actually execute what we draw and what we tell them and what we're specifying. At the end of the day, a lot are making mistakes, and that's where they're failing. If you know what I mean.
Yeah, I agree.
Maybe some more inspection, or more rigorous inspection.
Yeah.
To be honest.
And this is why in 2009, when they were talking about doing this QA on the thermal bridging junctions, treating them almost like a robust detail, that was the intention, to ensure that this sort of, because actually a lot of heat is being lost through the poor thermal bridging junctions. So this was the intention, and we, as BBS, we got all geared up to, we calculated all the thermal bridges and things like that, hoping that this is going to be carried forward. But unfortunately, we got stuck in an interim period that never ended, and now we've come to this release of the building regulations, and they've said no, they're shelving that completely. So it is a bit disappointing. But I think moving forward to 2016 and this intention to become zero carbon, that this gap is going to have to be addressed somehow. And I think at the moment it's something that obviously the Zero Carbon Hub are looking into, but in terms of the building regulations at the moment, I think there's not really any mechanism to do it, which is slightly unfortunate.
You mentioned that about the conflict between different building elements. One of the most common cold bridges is the reveals at the sides of windows.
Yeah.
And you see everywhere windows being put into the outer leaf because the contractors can fix them more easily.
Yeah.
But effectively, you need, in order to get a 1 watt reveal compliance with building regulations, you need to overlap the cavity barrier, something like at least 30 millimetres, possibly even 40. And you very rarely see that, particularly if you've got UPVC windows, which are probably only 70mm framed thicknesses as well.
Yeah, and this is the problem really, because us as SAP assessors sitting at our desk, we say, right, this is the detail you need to follow, and the architect ticks it and signs it and says, yes, that's what we're going to do. And then when they go out on site, obviously, I haven't really, I go on site quite often, but I'm not looking for those sort of details, and it's whose responsibility is it really to be checking that those sort of things are carried out. Because from my point of view as SAP assessor, I say, I'm done, I'm happy with that, we passed, move on to the next one. But there is a real problem that actually on site, when things aren't done properly, it can have a real effect, like you say, like condensation, things like that kind of effect. So definitely it's something to think about a bit more. Just moving briefly on to part L1B, there actually hasn't been a lot of changes here. No changes, in fact. And as everyone probably knows, it's related to conversions, refurbishments, extensions. As Paul said earlier, the consequential improvements that were due to be introduced in Part L1B to 2013 have been scrapped. So really there's not been a lot of change to Part L1B. I'll quickly just run you through the thermal elements. These are exactly the same as SAP 2009. Some of you may have worked with me if you've got overglazed extensions, so if you've got more than 25% glazing of your floor area, you sometimes need to have a SAP calculation done, and these are the sort of U values you'll be looking at. And if you're upgrading anything that's retained, if say you've got a wall that's a solid wall, the U value of over 0.7, then you should be improving towards the second column, which is the improved U value, as far as financially and viable within a sort of a 15-year payback, I think it is. So, but again, this hasn't really changed since that 2009, but I thought I'd just put it up there to show everyone. I'm going to just take you a little bit through Part 2A, L2A, which is non-domestic. So what they've done is they've done an aggregate approach to the carbon reduction. So we've got an overall a 9% aggregate reduction in carbon. When you look at the breakdown in the types of buildings, some have been subject to about a 14% reduction, others only about a 3%. Overall, we're looking at 9%. What the idea is to make it a bit easier for compliance with some of the more tricky ones to comply, like small warehouses and things like that. And they've actually introduced a wider range of notional buildings, because as I'm sure you can appreciate, the difference between part L1 and part L2 is that when you look at L2, there's so many different types of buildings. When in part L we're just looking at sort of dwellings, yes we have flats and houses, but in part L2 we've got difference between having a warehouse, a hospital, school, and there's lots of different types. The notional fabric U values have remained the same, except they've reduced the glazing requirement from 1.8 to 1.6, and the notional heating efficiency for the notional building has increased from 88% efficient to 91% efficient, and the fan coil unit specific fan power has been reduced to 0.3. So these are just sort of the headline figures. A couple of other minor changes. One of them is the lighting. So back in 2010, the actual lux level was irrelevant, and what they did was they rebased it to the notional building, which meant that you can pretty much overlight a really small space, and you weren't penalised. Whereas now they're actually looking at the actual installed lighting wattage. So it's just something to bear in mind, that you can't put loads and loads of high watt lights into a small space anymore. It's actually based on the actual lighting wattage. And within district heating, previously, if you put in district heating, the notional building was also applied to district heating, not just a standard gas boiler. So you weren't actually getting any improvement by putting district heating in or CHP. So now they've actually changed this, which I think was previous a bit of a mistake in the previous release. This should now give you a bit more benefit for putting in district heating or CHP in non-domestic buildings. And just a final little section on transitional arrangements. So as I said earlier, we're going live on the 6th of April 2014. Hopefully we'll all be ready. We're currently waiting just to have a look at the consultation SAP, the sort of the beta software. Bearing in mind this beta software has then got to be released to all the commercial SAP providers like the NHER and Stroma. Then they need to write their software. So we're hoping that by next April they will have all their software ready, but I mean that's just 5 months away, so we'll see what happens. This is the transitional arrangements this time are exactly the same as last time. So any new developments registered with building control after the 6th of April next year will fall under the new SAP. So up until then we can still be registering under current SAP 2009, but after that date you don't have a choice. You'll be going straight into SAP 2012, which is going to be hilarious because by that point it's going to be 2014, everyone's going to get really confused. But we're going to talk about the new SAP, which is SAP 2012, so we're just going to be a bit 2 years out of date, which is fine. So any developments that are registered prior to the 6th of April 2014, you're allowed to fall under SAP 2009, but you must start on site within 12 months to be able to use the previous version of SAP. And just a small section about what these are sort of things that you can use for start on site. So if you start digging some foundations, if you put in some drainage work for the building concerned, and bear in mind if this is a 100 unit site and you build foundations for just the first house, then that constitutes start on site. So unless any major changes are made which require resubmission to building control, you will then have secured that whole site under SAP 2009. These sort of things do not constitute start on site, so you can't go in there and just take a tree out and say, oh, we've started, or demolish an existing building. That's not start on site, and neither are any site servicing works like roads for trucks and things like that. As I just said, any resubmission which may affect your building regulation submission will obviously could mean that then part of your site will need to fall under the next version of the building regulations. Does that all make sense? If they've got any questions, if they want to run away and go home. I think actually from my point of view it's a little simpler than the change from SAP 2005 to 2009. There's not really any new elements. Like we were really quite focused last time on thermal bridging, and there was a lot of worry about psi values, party wall insulation, thermal mass. This time the overall structure of SAP has stayed relatively similar. We've just obviously got this new elemental recipe and this Duffy and Tuffy. So I think the main take home point is, again, fabric first. And yeah, if anyone's got any questions, please feel free to give me a call at the office and I will try and help.
Have you experimented with this diffy and tiffy with regards to different construction types, like timber frame and or is it conventional construction, block and brick? Does it vary? Does it give you better or worse values with regards to fabric?
This is what I was hoping to have been able to tell you today with looking at the trial software. Because we haven't been allowed access to the beta software, all the sort of standard little tests that we'd run through and have a look at, I haven't been able to do, but it's certainly something I'd look at when it comes out, and I'll let everyone know, because in terms of different constructions, timber frame versus brick and block, the main difference in that is obviously your thermal mass, and there hasn't been any real word on whether thermal mass has so much of an impact now.
Previously it was supposed to give more of an advantage to the traditional build rather than timber frame.
Yeah.
I'm wondering if it's the same.
Yeah, and I'm wondering too. Yeah, so I'm hopefully we're hoping for the software to come out in the next couple of weeks, and they're the sort of things that I really want to have a look at, because it's very different. Some of this information I went to the BRE about 6 weeks ago, and they gave us sort of a bit of information and did a quick run through of the beta software. But they won't let me get my hands on it yet. So once it's out, and I will be running through a lot more scenarios, looking a little bit about. We're not entirely sure about the effective orientation. We assume, because now it's based on a notional building, that actually it's going to be based on the same orientation. So it may well find that the previous version of SAP, we were really focused on getting lots of south-facing windows and things like that. It actually had a massive impact, probably like a 5 to 10% difference in the SAP. But at the moment we're slightly unsure about whether that's actually going to have any impact at all. So you might find that, whereas before different house types moved around the site would perhaps perform worse at a north orientation, things like that. We're not entirely sure yet, but that's something that we'll be looking at when we can.
Could you explain what is meant by zero carbon?
Well, I think my colleague's actually, my colleague's going to.
Tea first.
Yeah, no, I purposely didn't really say much about zero carbon at all, because Andy's going to run through a bit more about the definition. Yeah, okay.